All right, today we're going to talk about the complex number system. So the definition is that I equals the square root of -1. So you learned in Algebra 1 that you cannot take the square root of negative numbers, but now we are going to define I as the square root of -1. A more important thing to know, however, is that I squared equals -1. So if you look at I equals the square root of -1, if you square both sides, if you square a square root, you get the number back again. So I squared equals -1. So I is called the imaginary unit. And if we have complex numbers, they are numbers that can be written in the form of A plus BI, where A and B are real and I is the imaginary unit. And anytime you are giving answers that are in complex number form, you always want to put it in that A plus BI form. So there's lots of different types of complex numbers. 5 we know as a real number. But I also could write that as 5 plus 0i, so I could write it as a complex number. 3i is all imaginary, but again, I could write that as 0 plus 3i, and it is now a complex number. 2 minus 5i is imaginary and complex number. So all of these numbers are in the complex number system. And again, important to remember that the standard form is A plus BI. So if your answer is 2i plus 3, you want to make sure you switch it around and write it as 3 plus 2i. And there's lots of uses of complex numbers. Most of them, however, are beyond the scope of this course. So let's talk about how do we simplify radicals with negative signs underneath the radical. So this would be the square root of -4. I can rewrite that as the square root of -1 times 4. If I squared this, I could say I squared times 4. And now I can break it out, and I can say this is 2i. I think a simpler way of thinking of this, however, is to just take a look and say, all right, if I know there's a negative underneath the radical, I have to pull that out as an I. So the square root of -9 would just be 3i. The square root of -25 would be 5i. And the square root of -12, you would pull the negative out as an I and then simplify the square root of 12 to square root of 3. So this would be 2 square root of 3i, but very often when you are handwriting this, it is very difficult to tell whether the I is underneath the square root or not. So we tend to put that I in front of the radical symbol. So 2i square root of 3. This is a very interesting one. We have the square root of -8 squared. So I can write this as the square root of -8 times the square root of -8. But if you remember several lectures ago when we were talking about radicals, I told you that I can only multiply those together when they are real numbers, and these are not real, so I cannot make this the square root of 64. I have to simplify them first. I have to pull out the i's first. So I can make the first one I square root of 8, the second one I square root of 8. Now that these are simply 8s, now I can multiply them together. So I times I would be I squared. The square root of 8 times the square root of 8 would be the square root of 64. Well, if you remember, I squared is -1. Square root of 64 is 8. So this actually is -8. And again, if you go back to the original and say, oh, when I square a square root, I get the number underneath the radical back again, it also makes sense. So the square root of -10 squared would be -10. So let's talk, how do we simplify expressions that contain I? So when I'm simplifying expressions that have I in them, I can only have I to the power of 1. That would be simplified. So if it has a higher power of 1, you need to simplify it. Well, we know that I squared is -1. So this is really going to be 5 times -1 or -5. The second one here would be 3i squared. So this would be 9i squared, which would be -9. 2i to the third, well, that would be 8i to the third. But 8i to the third, if you think about I to the third, I can write that as I squared times I. I squared is -1, so this would be -8i. This next one, -3i to the fourth. Well, -3 to the fourth is a positive 81, and then I to the fourth. But remember, I to the fourth can be written as I squared times I squared. So that would be -1 times -1. So this would be positive 81. So let's take a look at what the pattern is for simplifying I. So we know I to the 1 is simply I. We also know that I squared is -1. Well, I to the third can be written as I squared times I. So that would be -1 times I, so that would be -I. I to the fourth I could write as I squared times I squared, so that will be +1. I to the fifth can be written as I to the fourth, which is 1, times I to the 1, which is I, so this would be simply I. And the same pattern can happen for I to the sixth. This would be I to the fifth, which is I, times I, so this would be -1. And you can see that this pattern starts to emerge where I have I, -1, -I, 1. I, -1, -I, 1. The most important thing to notice, however, when you take a look at this series is that every fourth power of I is 1. And we can use that to help us simplify higher powers of I. So if we want to simplify 4i to the 23rd, I'm going to take a look at that 23rd and I'm going to find a power of I that is a multiple of 4. Well, 23 is not a multiple of 4, but 24 is a multiple of 4. So I can either think of it as going 1 less, or I think it's easier to think of going higher. So I to the 23rd is not a power of 4. I to the 22 is not a power of 4. I to the 21 is not a power of 4. But I to the 20 is a power of 4. So I can write this as I to the 20 times I to the third. All right, we know I to the 20 is 1, so we can just cross it out. But we know that I to the third is -I, so this would just be -4i. 5i to the 82 simplifies down to -5. Let's see why. I can write this as I to the 80 times I squared. I to the 80 is a multiple of 4, so I can just cross that out. We know that I squared is -1, so this would be -5. -3i to the 48, well, I to the 48 is already a multiple of 4, so I can just cross that out and I get -3. And 15i to the 37, I can write that as I to the 36 times I. I to the 36 is a multiple of 4. I can cross it out, so this will just be 15i. I'm going to stop there for today, and we will continue in the next video.